Okay, so the first couple of problems are very similar to what we already did in the notes, where it's asking you, is it a combination or a permutation? So I'm going to skip those. Okay, so here it wants you to use the formula for combination to evaluate this combination. So 7, choose 3. So I want you guys to go ahead and practice the formula. Substitute in your numbers and see what you get when you work it out. So plugging in your numbers to the formula, you have 7 factorial over 7 minus 3 in parentheses, factorial, 3 factorial. What is 7 minus 3? 4. So you have 4 factorial, 3 factorial. Notice that the two numbers down there add up to 7, so that's good. All right, the bigger number in the denominator is 4. So I'm going to go ahead and count down to 4, 7, 6, 5, 4, but I'm going to stop there because I know that the rest of that is going to cancel with the 4 factorial that I already have in the denominator. But I still need to expand out the 3 factorial, so 3 times 2 times 1 is what I have. Because let's first see what can cancel. Okay, so the 3 cancels into the 6, leaving a 2. Then the 2's cancel, and then the 4 factorial cancels. Okay, so then you just have 7 times 5 left, which is, Carol? 35, good. All right, so 35 ways to make a combination of 7 items, choosing 3 at a time. So that's what we mean. That's what that means. We're only choosing 3 items. We're making groups of 3 from 7. Yes?
I forgot to cancel the 2s, but then I divided it at the end.
That's, yeah, and that's...
Is that on accident, or will that get you the same answer every time too?
Should get you the same answer. So the question was, she forgot to cancel the 2's. So she still had a 2 up here and still had a 2 down here. So then you ended up with 70 over 2, but then you'll still go ahead and simplify that fraction. So as long as everything is simplified correctly, it doesn't matter what order. Now the nice thing is, because we're only multiplying on the numerator and the denominator, and so then the fraction is division, and so multiplying and dividing, it's commutative as far as multiplication goes. So if you multiply first, then divide, or if you cancel first and then multiply, it all works out. We get 35. Fantastic. 25. Okay. So let me write this out a little bit bigger for you. You've got a combination of 8, choose 3, and that's being divided by a combination of 8, choose 7, but then we're subtracting 89 factorial over 87 factorial. Basically what they want to know is, can you follow order of operations in this problem? Do you know which portion you're supposed to do first? Maybe you have to work part of it out as, scratch work and then plug in your numbers back in. So where I would start is doing each of these combinations. So we want to do the combination of 8, choose 3, and then we want to do a combination of 8, choose 7. And so, work that out off to the side here. Okay, so go ahead and work out both of those combinations using the formula. With the first one, you have 8 factorial, and then we know we're going to do 8 minus 3, which is 5, so I'm going to skip that one. Just 5 factorial, 3 factorial. So I'm doing the subtraction part in my head now. So expanding that out, I've got 8, 7, 6, and then stop at the 5, because that's going to cancel with the 5 factorial. And then still expanding out 3, 2, 1. So the 5 factorials cancel. 3 times 2 is 6, so I can just go ahead and cancel that in one shot instead of in 2 steps like we did last time. And then all I have left is 8 times 7, which is 56. Good. Okay, so now the other one is 8 factorial, and then 8 minus 7 is 1, so 1 factorial, 7 factorial. And here I only have to count down to well, the 7, right? Count down to 7. 8, 7, and then I'm done because that's going to cancel with the 7 factorial that's on the bottom. And 1 factorial is just 1. Right, that's 8, right, because the 7 factorials cancel, and we're just left with an 8. Okay, so now I can substitute the 56 and the 8 into that first fraction. So I have 56 over 8. And then let me go ahead and expand this fraction a little bit with the 89 factorial and 87. Notice that if I start counting down from 89, 88, 87, notice the rest of that's going to cancel with the 87 on the bottom. So 89, 88, whoops, 88, 87 factorial will cancel with 87 that's already there. Okay, so now canceling some more, the 87 factorials cancel. What is 56 divided by 8? 7. So I'm left with a 7 there. So I have 7 minus, and then what is 89 times 88? Okay, so then 7 minus 7832? Negative 7,825. And that is your final answer. We have negative 7,825. Well done. Okay, you volunteer to help drive children at a charity event to the zoo, but you can fit only 7 of the 18 children present in your van. How many different groups of 7 children can you drive? Okay, so now that we have a word problem here, in this section, 11.3, even though it focuses on combination, it's going to give you a mix of combination and permutation problems. So you have to be able to identify what type of problem this is. So is this a combination or a permutation? Okay, why a combination? Because order doesn't matter. The order and how the kids get into your van does not matter. It's the same group of 7 kids. All right, so this is a combination. And so how many students do we have total? 18, and we are only choosing 7. So that's the problem that you're working out. Combination of 18, choose 7. So in our formula, that means we have 18 factorial over 18 minus 7 factorial. 7 factorial. What is 18 minus 7? Okay, so we have 11 factorial, 7 factorial in the denominator. So then we can count down 18, 17, 16, 15, 14, 13, 12, 11. Okay, so notice as the numbers get bigger, it gets a little bit more complicated as a problem. So we can count down to 11 because that will cancel with the 11 on the bottom. But we still need to expand out the 7. So 7, 8, well, I'm going in the wrong direction, sorry. Counting down, 7, 6, 5, 4, 3, 2, 1. All right, I know my 11 factorials are going to cancel. What else? Okay, 7 goes into 14 2 times. Okay, 6 goes into 12 2 times. 5 into 15 3 times. Okay, 4 into 16 4 times. Okay, 3 into 18 6 times. 2 into 4 or 2 into 2. Okay, notice you have some options here. I can just say this 2 with this 2 now. It does not matter if you cancel in a different way. If you notice we did 3 into 18 gave us 6, but we could have also canceled that 3 with the 3 that we have in red. So it doesn't matter what order you cancel. You'll still get the same answer based on what you have left to multiply. Okay, so all that we have left to multiply now is the 6, the 17, 4, 3, 2, and 13, based on how I canceled it. So multiplying this all out, what do you get? 31,824. Does everybody agree? Okay, good. Okay, so 31,824, is that right? Did I type it in right? Fantastic. Okay, in a race in which 5 automobiles are entered and there are no ties, in how many ways can the first 3 finishers come in? So the first question you have to ask yourself is this a permutation or a combination? You say permutation, why? Okay, because there's an order that people are coming in, right. So order matters in this one because if, somebody's going to be first place, somebody else is going to be second place, and somebody else is going to be third place. And those, depending on when you finish, will give you a different order of first, second, and third place. So this is a permutation of how many total items? 5, choosing 3. Okay, so we have 5 factorial over 5 minus 3 in parentheses factorial, and we stop. We don't do that extra 3 factorial. That's the difference between a permutation and a combination. So what is 5 minus 3? 2. So you have 5 factorial over 2 factorial. So 5, 4, 3, 2, and we can stop. So we have 5 times 4 is 20, times 3 is 60. So our answer is there are 60 different ways we can have the first 3 finishers come in. There's only, in a permutation, there's only going to be 1 factorial in the denominator, so it'll just cancel with part of the top. It'll always cancel out. You don't have to expand it out. Whereas in a combination, there's 2 factorials, so only one of them will cancel outright. The other one you have to expand out to see what else it's going to cancel with. You'll always end up with a whole number because you can't have, 60 and a half ways for something to happen. So you're always going to get an answer of a whole number here. It should be positive. Now, the difference was in the last problem, we had a negative answer, but it's because we weren't just trying to find out the number of ways something can happen. It was a whole arithmetic problem where we had to substitute numbers and things were being subtracted and so on. All right, so this one was 60 ways. Excellent. And then there's one other problem I want to show you before we move on. How many different committees can be formed from 12 teachers and 46 students if the committee consists of 3 teachers and 4 students? Okay, this one would be good to put in your notes because this is probably the highest difficulty problem that you have in here. So you want to make sure you have something later to refer to. So again, you've got 12 teachers and 46 students, but you want the committee to consist of 3 teachers and 4 students. What's different about this problem as opposed to the previous ones? Because students need to go with students and teachers need to go with teachers. That's one way you can look at it. Right. Notice here we have 2 different groups. With all the other problems, you just had one group. And, well, first of all, let's ask, is this a permutation or a combination? Combination, good, because the order in which you select the teachers and the order in which you select the students doesn't matter. But if you try to select all 7 members from all of the teachers and students at once, then there's no guarantee that 3 of them are going to be teachers and 4 of them are going to be students. So you have to break this up into 2 groups. So we're going to start with a combination, let's say a combination for the teachers. And so we have a total of 12 teachers, and we want to choose 3. And then we need a combination for the students. We have a total of 46, and we are choosing 4. Now, once we finish these two combinations, we're going to have so many ways that we can choose the 3 teachers and so many ways that we can choose the 4 students, and we're going to have 2 answers. And what we do with these 2 answers brings us back to section 11.1. What did we do in 11.1 when we had so many ways to choose one item and so many ways to choose another item? Multiply, right. So once we finally find out the 2 answers, we're going to actually multiply these 2 together, because that brings us back to the fundamental counting principle, that if you have so many ways to choose one item and so many ways to choose another item, then just multiply those ways together to find the total number of ways to group them together. Okay, this problem is going to appear in many different ways. It could be teacher-students, it could be Democrats, Republicans, it could be, parents and children. So the main thing you want to pay attention to is, do you see 2 separate groups that need to be chosen from? And therefore, if you do, then you're going to use this process right here. All right, so off to the side, 12, choose 3. We have 12 factorial, and then what is 12 minus 3? 9 factorial, 3 factorial. Good. So 12, 11, 10, and then 9, we can stop there because that's going to cancel with the 9 factorial. I still need to expand out the 3 factorial. Okay, so the 9 factorials cancel. 3 goes into 12 4 times. And then 2 goes into 10. I actually like to leave my 10 in there because it's really easy to multiply by 10. I would choose to do 2 into 4 again 2 times. But that's your preference. It doesn't matter. But 2 times 11 is 22 times 10 is 220. Okay, for our other one, we've got 46, choose 4. So 46 factorial up top. What is 46 minus 4? 42. And then 4 factorial. So 46, 45, 44, 43, and then 42 is where we can stop. The 42 factorial on the bottom is there, but expand out the 4 factorial. Okay, 42 factorial cancels. 4 goes into 44, 11 times, good. 3 goes into 45, how many times? 15 times. 2 goes into 46, 23 times. And then you have 23 times 15 times 11 times 43. What do you get for that answer? Say that a little clearer. 163185. Okay, everybody get that? 163,185? Yes? Okay, so now putting these numbers back over here, the number of ways we can choose the teachers is 220, and the number of ways that we can choose the students is 163,185. And now the last step is to go ahead and multiply these 2 answers together. Okay, 35,900,700. Everybody agree? All right, so 35,900,700. Good job.